7.5 Logistic Growth. Example 1, finding a partial fraction decomposition. Write the function f of x as a sum of rational functions with linear denominators. Let's start by factoring the denominator. We have x minus 13 over 2x and x. Then we need to get this negative 7. So how about minus 3 and minus 1? We have negative 6, negative 1, there's negative 7. Now we're going to turn this into fractions with linear denominators. So we want a over 2x minus 1 and then plus b over x minus 3. Now let's get common denominators. We need to multiply this one on the top and bottom by x minus 3 and this one on the top and bottom by 2x minus 1. So we have 2x minus 1 down here and x minus 3 here. Now all of them have the same denominators. Now in order to solve this, we don't need the denominators. We have x minus 13 is equal to a times x minus 3 plus b times 2x minus 1. In order to find a and b, let's let x equal 3, and 3 makes that factor 0. When we plug 3 in for x here, we get negative 10 is equal to, this piece will be 0, and then 6 minus 1 is 5. We have 5b, and we find out that b equals negative 2. Let's let x equal 1/2. That makes this one 0. We have 1/2 minus 26 halves. That's negative 25 halves. And that's equal to 1/2 minus 6 halves. That's negative 5 halves a. Well, when we multiply by negative 2/5, we have some stuff that'll cancel out. So multiply by negative 2/5. The 2's cancel, and then 25 divided by 5 is 5. A turns out to be positive 5. Well, now we're saying that the original problem is now turned into, we have 5 over 2x minus 1, and then minus 2 over x minus 3. In exercises 5 through 14, evaluate the integral. Well, we can't use u substitution because the derivative would be 2x plus 1, and this is 2x plus 16. But if we turn these into partial fractions, we'll be able to integrate. We have 2x plus 16 over, let's factor the denominator, x plus 3 and x minus 2. And we want to turn that into a fraction with linear denominators. So we want this to be a over x plus 3 and then plus b over x minus 2. Let's get common denominators. We need to multiply the top and bottom by x minus 2 on this one and the top and bottom by x plus 3 on this one. Well, now that we'll have common denominators, we don't need them to solve this. We have 2x plus 16 equals a times x minus 2 plus b times x plus 3. Let's let x equal 2. We have 4 plus 16, that's 20. This part will go to 0, that's why we picked 2. And then this one will be 5b. b is now equal to 4. Let's let x equal negative 3. We have negative 6 plus 16 is 10, and negative 3 minus 2 is negative 5. A is equal to negative 2. Now we've turned the original fraction with a quadratic denominator into two fractions with linear denominators. Well, now we can write the integral of a is 2, but a is negative. We try to put the negative one second if we have a choice between a positive and a negative. So let's write the b first. We have 4 over x minus 2 and then minus 2 over x plus 3. The antiderivative of 1 over x minus 2 is a natural log. We now have 4 natural log of the absolute value of x minus 2 and minus 2 natural log of the absolute value of x plus 3, then plus c. Well, one of the properties says we can bring that 4 back up to an exponent. We don't need the absolute value now because anything to the fourth is going to be positive. And with this even exponent, we don't need the absolute value on this one either. And then plus c. Well, then we can combine these two natural logs with division. So here's our final answer. Natural log of x minus 2 to the fourth over x plus 3 squared and then plus c. On number 8, if the powers are exactly the same, or if the top power is bigger, our first step is long division. So we're going to take x squared minus 6 divided by x squared minus 9. X squared minus 6. X squared goes into x squared one time. That's a 1. We have x squared minus 9. And with long division, we always subtract. Negative 6 minus negative 9, that is 3. So now we've turned this problem into 1 plus 3 over x squared minus 9. And of course, we're still doing the integral. We're going to change this into partial fractions, in other words, fractions with linear denominators. We have 3 over x plus 3, x minus 3. That's equal to a over x plus 3 plus b over x minus 3. Well, now we need common denominators. We're going to multiply this one on the top and bottom by x minus 3, and this one times x plus 3. Now 3 equals a times x minus 3 plus b times x plus 3. Let's let x equal 3. We have 3 is equal to, this piece is 0. We have 6b. b is 1/2. Let's let x equal negative 3. We have 3 equals negative 6a. a equals negative 1/2. And like I said, we always try to make the negative last. We always try to make the positive first. Well, now we're integrating 1 plus 1 over 2 times the b went with x minus 3. And then minus 1 over 2 times x plus 3 dx. The integral of 1 is x, and then we have plus 1/2 natural log of x minus 3, and then minus 1/2 natural log of x plus 3. And then, of course, plus c. X plus natural log of the square root of absolute value of x minus 3, and then minus the natural log of square root of absolute value of x plus 3 plus c. But now we can combine the two natural logs. We have x plus natural log of the square root of the absolute value of x minus 3 divided by x plus 3, and then plus c. In exercise 15 through 18, solve the differential equation. Well, the powers are exactly the same. We have to start by doing long division. T to the third minus t divided into 2t to the third. T to the third goes into 2t to the third 2 times. We have 2t to the third minus 2t. And in long division, we always subtract. So that gives us 2t. We've now turned this into g prime of t is equal to 2 plus 2t over t to the third minus t. Well, we're supposed to solve the differential equation, which means we're going to integrate both sides. G is equal to the integral of 2 plus 2t over t to the third minus t, and we're taking the integral with respect to t. Let's turn this piece into partial fractions. We want linear denominators. That means we're going to have 2t over t times, let's see, if we take a t out, we'll be left with t squared minus 1. So we have t plus 1, and we have t minus 1. That's going to be equal to a over t plus b over t plus 1 plus c over t minus 1. Let's get common denominators. We need t plus 1, t minus 1. On this one we need t and t minus 1, and here we need t and t plus 1. 2t now is equal to a times t plus 1, t minus 1, plus bt times t, that's a minus, can't hardly read my own handwriting there, and then plus ct times t plus 1. Let's let t equal negative 1. We have negative 2 is equal to, negative 1 makes this 0, negative 1 makes this one 0, so we're left with the 1 in the middle. And we have negative 1 times negative 2. That's 2, 2b. b equals negative 1. Let's let t equal 1. This becomes 0, this becomes 0, and we have 2 times 1 is 2. We have 2 times 1, 2 is equal to 2c. c is equal to 1. And then we can let t equal to 0. 0 makes b 0, actually not b, but this part 0. 0 makes this piece 0, and we're left with a times 1 times negative 1, so that's negative a. So negative a is equal to 0. a equals 0. Because when you plug 0 in for this t, you get 0. Now we have the integral of, we start with the 2, we have the integral of 2, and then we want the positive one first. We have plus 1 over t minus 1, and then minus 1 over t plus 1 dt. The integral is 2t plus the natural log of the absolute value of t minus 1, absolute value, and then minus natural log of the absolute value of t plus 1, plus c. 2t plus the natural log of the absolute value of t minus 1 over t plus 1. In exercises 19 through 22, find the integral without using the technique of partial fractions. Well, in number 20, we don't need partial fractions. We have a function and its derivative. We can let u equal 2x squared minus 3x plus 1, and then the derivative is 4x minus 3, and that dx, that's exactly what's on top here. Well, now this becomes the integral of, we have 1 over u du, and then the integral is the natural log of the absolute value of u, which is 2x squared minus 3x plus 1, and then plus c.